Okay, so continuing with the equations, we're going to do the logarithmic equations. So we have log base 3 of x is equal to 2. So what you're going to do is we are going to rewrite the log equation into an exponential equation because we cannot solve these logs with the log present, okay? So we're going to rewrite it in exponential form. 3 to the second power is equal to x. So my x is already isolated. All I have to do is simplify. 9 equals x and you're done. And you can plug it in and be able to check it and you'll see. Sorry, I had to fix that. Okay. Alright, so let's look at another equation. Log base 7 of x plus 7 is equal to 2. So we have a base 7, the exponent is 2, and that equals x plus 7. So we simplify and solve for x. 49 is equal to x plus 7. So x is 42. And you can always plug it in and simplify so that you can check it. So I'm going to check this one just so you can see how it works. So this is saying log base 7 of 49 is equal to 2. So 7 squared equals 49. And 49 equals 49. So that's good. And it's correct. Okay? Now, another thing is if we have logs that are in an expanded form, log base 6 of x plus log base 6 of 5x minus 1 is equal to 1. So here we cannot do anything with this because our goal in log equations is to put it in exponential form. But we cannot put this in exponential form until we condense it, okay? Because you can only condense from a single log. So my condensing, I'm going to pull out a log 6 and it's going to condense into a multiplication. Okay, so now we're going to rewrite this in exponential form. 6 to the 1 is equal to x times 5x minus 1. So now you just have an equation that you need to solve. So we're going to factor this. So I'm going to get x equals 6 over 5. And I'm going to get x equals negative 1. Now, when you're doing the logarithm equations, you cannot have an answer that will create an m here. In either one of those positions, that's negative. Okay? So see that the negative 1 would not be able to work. So we have to take it out. So our answer is x equals 6 over 5. And that's your answer for that. Okay? So anytime you have multiple logs in an equation, you're going to have to condense it. All right? Now, the other type of logarithm equations that you may see are those that are written in natural log form. Okay? So, one thing I want you to understand is that anytime that you have a logarithm, a natural log, or an exponential piece, you have to isolate that piece of the function. So basically what I'm saying is the 5 has to move because you only want the natural log there, okay? You don't want a coefficient. So we're going to divide both sides by 5. All right? So by doing that, I need to do something with this natural log. One thing you have to know about the natural log is that the natural log is just log with a base e. So by just rewriting the natural log with a log base e, you can now use your rule of logs to solve the equation. We solve logarithm equations by putting it in its equivalent exponential form. The base is going to be 4. The base is going to be e. The exponent is going to be 4, and it's going to equal 7x. Okay? So now I just solve for the variable. That's my exact answer. E to the 4th divided by 7. I'm going to put that in my calculator. Remember, e is a function of its own, so you can press the e button directly on your calculator. And this final answer is going to be 7.80. And those are logarithmic equations.